All right, hello everyone out there. I'm Thomas, and welcome to my channel. I do educational videos on topics esoteric and obscure, um, mostly. And we've been doing a little course here on the reciprocal system of theory, originated by Dewey B. Larson back in the middle part of the 20th century. And updated in the 21st century by Dr. Bruce Perret and Dr. KVK Nehru and others. And we've been reading over an address that Larson gave to the ISIS, the International Society for a Unified Science. And this is a 1986 talk that he gave called The Outline of the Deductive Development of the Reciprocal System. At this point, Larson was 88 years old, I believe, and coming to the end of the road. But he has already been kind of working on his theory for like over 50 years by this time, and so he's trying to lay out his thought process, because that's how the reciprocal system goes. He's got, two original postulates. Universe is made out of motion. Motion is the relationship between time and space. Space and time are the same, except that they are reciprocals of each other. That's paraphrasing. And then the other postulate is in dispute from Perret and others, but it's basically that the universe conforms to the laws of commutative mathematics, and its something are absolute. Its measurements are absolute, or and its geometry is Euclidean. And Perret disputes that, says that Euclidean geometry is a subset of the reciprocal system. Part of the reciprocal system is in Euclidean geometry, but there's a geometrical cascade that occurs from projective geometry to affine geometry to metric geometry, then to Euclidean geometry. So Euclidean geometry is just a special case of the universe. So, and I think Larson might have actually agreed with that had he known about these more modern geometries. But he felt like it was going to confuse matters even more than they already were. And that's kind of the case with Larson, and to a great extent, is that this subject matter seems so difficult because he's trying to undo this whole system of lies of the mainstream legacy science, lies and half-truths and rationalizations and all these things. And he's trying to figure out how he fits into it, because he's a scientist himself. So he is somewhat invested into all this science, but at the same time he's got this different theory. And he even says that 90% of legacy science fits into his theory, but it's the 10% that he's going after, the realm of the very small, the very large, the very fast, the very slow. And but so he's in this article, he's just laying out step by step how he developed the system. We're up to number 32. Development number 32. If the scalar motion is less than three-dimensional, the basic photon will move outward as radiation in a vacant dimension, and the motion combination will disintegrate. In order to be stable, the rotationally distributed motion must therefore be three-dimensional. Okay, so the photon is just a one-dimensional kind of nullification of the progression that at light speed, and that's why it still moves at light speed, because it still has these two free dimensions. But you have to nullify all three of the dimensions before you have something stable that you can work with, which would be like an atom. And that's what he calls gravitation, is the three-dimensional inward motion that nullifies the three-dimensional outward motion that he calls the progression of the natural reference system, which we see both by the progression of time and its equivalent, the progression of space, which is the recession of the distant galaxies. Okay, now to move to number 33, the three-dimensional combination of vibrational and rotationally distributed motions appears in the reference system as an identifiable object moving inward in all directions. We identify such an object as an atom or a subatomic particle. Collectively, the atoms and particles constitute matter. Okay, so you need a three-dimensional combination of vibrational and rotationally distributed motions. We identify mass, this is number 34, we identify mass as a measure of the net magnitude of the rotationally distributed scalar motions of matter. We identify the observable inward directed effects of this motion as gravitation. The magnitude of the gravitational effect is therefore directly proportional to the mass. Okay, number 35. The inward gravitational motion of the atoms results in the formation of material aggregates of various sizes. In these aggregates, the atomic motions and masses are independent and additive. Number 36. The outward motion due to the progression of the natural reference system always takes place at unit speed, regardless of the size of the aggregate or the distance that is involved. The net relative motion of any two gravitating objects with no additional motions is the algebraic sum of the unit outward motion and the unit inward motion. Okay, so you just add them together. It's really more like subtracting them. Because of the spherical distribution of the gravitational motion in the reference system, the magnitude of the motion of one unit of matter toward another is inversely proportional to the square of the intervening distance. Okay, that's again the gravitational inverse square law. Okay, now number 37. At relatively short distances, gravitation predominates, and the net motion is inward. Since the gravitational motion decreases with distance, while the outward progression remains constant, the opposing motions reach equality at some greater distance, which we will call the gravitational limit. Beyond this distance, the net motion is outward, increasing with distance, and approaching unity at extreme distances. This theoretical pattern of net speeds is verified observationally by measurements of the Doppler shift in the radiation received from the distant galaxies. And so this is like the red shift. The further away these astronomical bodies are from us, the faster they're moving away from us. And that's because all of these bodies are outside of the gravitational limit. So inside the gravitational limit, bodies tend to move toward, like we'll say, of Earth. Inside the gravitational limit of Earth, bodies tend to move toward Earth. Outside of that gravitational limit, the bodies will tend to move away. And if it's very, very far away, the further away, the closer to the speed of light that the body is moving away. Now, this is complicated somewhat by the sun and the solar system. So, we can look and calculate the Earth's gravitational limit, and he does have an equation for that. But even if we get outside of the Earth's gravitational limit, we still, at least at the start, are within the sun's gravitational limit. So even if something is far enough away from Earth so that it doesn't fall into Earth, it's still within the sun's gravitational limit. And given that the sun is like 1,000,000 times more massive than the Earth, the sun's gravitational limit is much longer, much larger than the Earth. Now, he eventually, has a couple of different gravitational limits that eventually he'll talk about, we'll talk about. But for the sun, the gravitational limit is gigantic. Okay. So the gravitational limit, the first gravitational limit anyway, is like an island. So everything within that eventually will come crashing into the sun. But anything outside of that is then in free space, unless it's within the gravitational limit of some other star. But the gravitational limit of the sun is something like 3.61 light years. And so that's a huge, huge bubble that the sun has, that basically it possesses everything within that. If you go all the way out to Pluto, at the edge of the solar system, and this is all even if you believe that there is a solar system and that space exists, and that all of this is not fake. Even if you go all the way out to Pluto, I think Pluto is like less than 1/1000th of a light year. So we're talking about 3,000 over 3,000 times as far as Pluto is the sun's realm. And Bruce Perret has strongly pushed back on this whole thing, and he thinks that he basically adjusted the equation for the gravitational limit. He buys in much more into the astronomy of Barham Carteret, if I'm pronouncing that correctly, who really says that the distances between the stars and even the planets is way off base, and that within 1 light year of here, there are all kinds of other stars and star systems and planetary systems, and that I think Perret goes and recalculates the gravitational limit, and it shoots it down by like a factor of 1,000 or something like that. So anyway, just to say that this is something that is contested, number 37, even though Perret doesn't put in a footnote here. Okay, number 38, the conventional spatial reference system in conjunction with a clock for measuring time represents a physical situation in which the space component of the progression of the natural reference system is neutralized by gravitation, while the time component progresses at the full normal rate. In this reference system, the space progression, as indicated by the motion of a massless object, appears as a one-dimensional motion through three-dimensional space. So that's the progression of space, recession of the distant galaxies, and then also the progression of time, which is scalar motion. So it's always getting later and later and later, but there's no particular direction. Number 39, since we postulate a reciprocal relation between space and time, each of the deductions expressed in the foregoing numbered statements is also valid in the inverse form, that is, with space and time interchanged. Number 40, we identify the time component of the progression of the natural reference system as the flow of time registered on a clock. It follows from the foregoing that motion in time, this is number 41, motion in time takes place in 3 dimensions in the same manner as motion in space. The time component of the progression of the natural reference system, or clock time, is a 1-dimensional outward motion through a stationary 3-dimensional temporal system of reference, in which independent motions at different speeds and different directions also take place. Motion at unit speed, number 42, motion at unit speed causes unit change of position in both the spatial reference system and the temporal reference system. It is a motion in time as well as a motion in space. Okay, number 43. When motion takes place in time, the constant progression analogous to clock time is in space and would be measured by some kind of a space clock. But the rates of progression are the same, 1 unit of space and 1 unit of time per unit of motion. Thus, the measurements relative to the space clock are identical with those relative to a clock that registers time, if expressed in the same units. Number 44. As noted, the space-time ratio in the units of motion is fixed at unity by the reciprocal postulate. It follows that a reduction of speed, as for instance by an increase in the distance between gravitating objects, does not alter the ratio of space to time in the effective motion. It reduces the proportion of the total motion that is effective in increasing the spatial separation of the objects. This effective portion of the motion increases the separation by x units of space per 1 unit of clock time, where x is a fraction, and because of the fixed relation between space and time in the individual units, also increases the separation in time by x units. Okay, number 45. Where only one motion is involved, the x units of time are coincident with the time progression and do not enter separately into the determination of the speed. But if 2 objects are moving, their relative position in space may change at a rate exceeding unity by some quantity. From the previous 44, the change in the separation in time then also exceeds unity by x. The speed is the quantity 1 plus x over the quantity 1 plus x, which equals 1. Thus, if at least one of the 2 objects is a photon or other object moving with unit speed, the relative speed is always unity. And this agrees with statement 8. This is the explanation of the observed fact that the speed of light is independent of the reference system. Okay, this is number 46, and the last one we'll do today. Where motion at a speed greater than unity, motion in time, takes place under conditions that preclude actual changes of position in time. This motion acts as a modifier of the spatial motion, that is, a motion in equivalent space. The spatial equivalent of a temporal magnitude x is 1 over x. Okay. A lot of stuff there, probably too hard to follow for everybody, too hard to follow for me even, and I've been studying this stuff for 20 years. Larson writes in such a dry manner that, like I said, so many prepositional phrases, it's very hard to keep track. So I'm recording this. You can go back and listen to it over and over again if you need to. But just don't get discouraged. This is just an overview. This is just to give an idea of how Larson thinks and how this is developed. We'll get into these more specific items in more detail later on down the road. But I just wanted to lay this down as a foundation. Okay, so have a great day, and we will see you next time, starting with number 47.